Hello everyone, and welcome to the Overwhelmed by Vulnerability Triage, here a blend of finest best practice session. It's such a great honor to be here at OWASP Global Virtual, giving this talk despite everything that's been happening through these troubled times. It's such a warmer feeling seeing the community coming together, allowing these events to still happen. But before we start, we would like to thank OWASP for the opportunity, checkmarks, especially to Application Security Research Team for their help and guidance, and you, who are joining us around the globe in the whole spectrum of time zones. My name is Jorge and I'm an Application Security Analyst at Checkmark's Application Security Research Team. I really like to spend my time exploring new technologies, CTFs, learning new methodologies of attack, surfing, reading, and playing guitar. I'm giving this talk with my colleague and friend Eduardo, who's also an AppSec analyst at Checkmarks. Eduardo?
Hello everyone, I'm Eduardo and it's a pleasure to present at OWASP Global AppSec with my partner Jorge and share some knowledge with the security community. As told by Jorge, we work at Checkmarks as AppSec analysts and our focus is to read and review code with a security mindset. Also, I like to practice my hacking skills with CTFs and sometimes touch a little bit in hardware to learn about a different subject. In my free time, I love to do sports and read a good book, mainly related to technology. Now, let's start our presentation with Jorge.
Thanks, Eduardo. So, having worked with application security testing tools in our daily routines, we have seen how these solutions are capable of detecting and identifying large numbers of suspected security vulnerabilities in the software we have scanned. However, that comes with a price. The sheer number of test results can be somewhat terrifying due to the work required to triage the significant numbers of detecting code errors. Remediating coding errors that could lead to exploitation takes lots of time and effort. And questions such as, what if there's a critical vulnerability that was triaged incorrectly? What if that vulnerability could lead to an attacker compromising the application? What if we, as application security analysts, missed something due to time resource constraint? These questions are always top of mind for anyone performing a SaaS result analysis. There is no shortage of things that can go wrong when trying to triage many results. So, in this talk, we will firstly summarize what distinguishes SAST from the other AST solutions available on the market today, its role within the software development lifecycle, plus we will cover SAST pros and cons. Next, we will focus on the importance of having an AppSec team triaging the results from these SAST solutions and the impact the team has on CI/CD workflows from the developer's perspective. Then, we will illustrate our list of checks and security best practice, which we use internally on this type of analysis, can be used to streamline your triage efforts. So, the fast pace of releases and the speed of DevOps demand automated and accurate security testing tools that can be easily scaled and capable of producing actionable and fast results for the organizations. In this section, we will look at the core differences between three different testing solutions: SAST, HIAST, and DAST. These are application security testing methodologies, tools, used to find security vulnerabilities that can make an application susceptible to attack. Static application security testing is a white box method of testing that examines the code, or binary itself, to find software flaws and weaknesses. Working as a developer approach testing methodology, vulnerabilities are found earlier in the SDLC, making remediation faster, easier, and cost-effective. Differently, IAST, which stands for Interactive Application Security Testing, is a dynamic and continuous security testing solution that works through software instrumentation. This happens by deploying agents in running applications and continuously analyzing all application interactions, initiated by automated and/or manual tests to identify vulnerabilities in real time. On the other hand, dynamic application security testing, DAST, is a black box testing method that examines an app from the outside, looking for vulnerabilities that an attacker could exploit. A tester using DAST examines an application when it is running and tries to hack it, just like an attacker would, basically simulating a hacker's approach. All these methodologies have their strengths and weaknesses and should be part of every effective security program. Eduardo is going to continue to sum up these major differences, which may function as little tips for helping you choose the right tools for your needs. Eduardo?
Thanks, George. Starting with SaaS. SaaS solutions are considered the best when it comes to integration into the development process. The application code is scanned automatically. Incremental SaaS scans are launched with each pull request, and vulnerabilities are detected early in the product lifecycle. Static analysis can be used not just for security purposes. A SaaS tool can be integrated with the IDE as it provides immediate feedback to the developer on issues they might be introducing into the code. Also doesn't need to compile the code. You have access to the source code. You can even scan parts of the application instead of scanning the whole application. About IAST. IAST uses agents and sensors to continually analyze the application. IAST can work during automated testing, manual testing, or a mix of the two. The main difference of IAST from both SaaS and DAST is that it operates inside the application. Also can analyze a running app as is instrumented within the application and identify vulnerable code. IAST has this ability because it's part of the application itself and can indicate where is the vulnerable code. There's no need to have access to the source code of the application being tested. What about DAST? A DAST tool needs a proper testing environment to analyze an application, and it is as good as the expertise of the tester to write test cases. If the tester is good, you will get good results, but if not, you will not get what expected from this service. Moreover, DAST is easy to run because it does not have access to the code. It just needs a full working application to test it, but requires a full compilation upon every code change. This happens because DAST tools don't have the ability to read or compile code. The exposed findings are realistic vulnerabilities because they simulate a real attack. This means if the DAST attack was successful, the application can be exploited in production. DAST can also expose third-party vulnerabilities. Nowadays, a lot of our code is based on multiple third parties, and DAST does not depend on the code itself. It tests anything built in the application, including third-party code. A controversy for a DAST tool is it cannot detect non-reflective attacks. Non-reflective attacks are attacks that do not return a response. In resume, DAST does not suggest where to fix the problem, only says that exists a problem. Regarding IAST, IAST does not require applications to be attacked to find vulnerabilities. By just browsing the application, IAST leverages its visibility of source code and execution flow inside the app to detect security risks in real time. Also can detect non-reflective responses and be used as a complement to DAST. As is part of the application, third-party code is reviewed as part of the process. About SaaS, on one hand, scans all the application code developed by the programmers. On the other hand, is not able to scan third-party code because their code is only available at runtime. After an overview of the three principal AS technologies, we will talk about how a SAS or static code analysis tool fits in the SDLC. This section also points the techniques used by SAS to find application flaws and how they can help developers secure their code. Following security guidelines and coding standards at the coding stage is a critical task. Using automation tools, such as static analysis tools, is a key to ensure that vulnerabilities are not introduced into the product. The way the software is constructed is the main origin of software security problems. Static analysis tools can find errors early in the development stage, even before the program is running for the first time. Finding an error early not only reduces the cost of fixing the error, but also helps to guide a programmer's work. A programmer can correct mistakes even before he's aware they could even happen. The cost to fix a production application is much higher than fixing vulnerabilities while they are being introduced, mainly during coding stage. So, how SAS can identify vulnerabilities or code issues? One of the main points is continuous source code and security assurance. Static analysis is often applied initially to a large code base as part of its initial integration. As each new code block is written, it can be scanned by the static analysis tool, and developers can deal with the errors and warnings quickly and efficiently before the code gets into the build system. Detecting errors and vulnerabilities at the source code, and this includes developers themselves, yields the biggest impact from the tool. In the same way, source code analysis permits data flow analysis, which determines how data flows through the code. The most common way to perform that is taint analysis. This approach is useful to find untrusted data is used by sensible functions which need trustful data. The basic idea of taint analysis is to follow the data flow in order to understand if the input provided from application sources reach sensible functions. Another good help is secure coding standard enforcement. Static analysis tools analyze source syntax and can be used to enforce coding standards. Various code security guidelines are available, such as MUSERA. Coding standards are a good practice because they prevent risky code from becoming future vulnerabilities. At this point, we have an overview of how static analysis tools are integrated into the SDLC and how they look for vulnerabilities. But like other tools, they have advantages and disadvantages. Jorge is going to talk about them. Jorge?
Now that we understand SAST's position over the other two methodologies and its role on the SDLC, we can sum up its strengths and weaknesses by overlighting the following pros and cons. I'm going to start with the bad news. Out of the box, most SAS tools produce thousands of false positives on an average size application, requiring some customization, mainly by turning the queries rules of your SAS tool into your application's environment. Also, as a standalone solution, most of the SAS tools available do not pinpoint vulnerabilities found in third-party components. However, this can be mitigated by having some additional modules, software, which looks for vulnerabilities in libraries and so on. Another disadvantage of SAS solutions is that it has no visibility of the execution flow. Thus, it is not capable of identifying vulnerabilities in runtime environments. Looking at the bright side, SAST has many strengths to offer. It not only works on any type of application, but also it does not require a deployed app, allowing you to run a scan on any kind of file you want in your application. It can also be run repeatedly, as with nightly builds or continuous integration, scaling really well. The output of the scans are a great guidance for the devs. A major part of SaaS tools highlights the source files, line numbers, and even subsections of lines that are affected with the complete flow. Eduardo?
Thank you, George. We have talked about application security tools, but it is important to have people focused into understand not only the technology side of the business, but also how application security can impact the overall business. This section is about how an application security team can help to improve the security awareness, advice, and ensuring the organization is making secure software. The purpose of the security team is not to give orders with no reciprocal relationship. In this way, finding the application security champion is an important thing. Even if you plan to target programmers as the main consumers of the information generated by the tool, having the security team participate is a huge help for them. Choosing an application security champion is a way to improve the communication between the application security team and the development team. The AppSec champion is someone that can help developers with security concepts and help the application security team to better understand how the development works. Moreover, developers mostly are focused into build and deliver code. The need for delivering can avoid coding with security best practices. If the systems and applications we are creating need to be designed securely, then education needs to start with the people creating them, the developers. You could have the most capable security solutions and a huge security team, but if the developers working on your application don't understand the importance of security or know what to do to help the organization release secure software, you will have a constant setback at release time. Also, the application security team can spread awareness, not just to the developers, but to the entire organization. They can show the impact of a vulnerability can have and why it's important to developing a secure code. This can also be done by doing trainings. Security teams are a great resource to share knowledge. Furthermore, as developers are focused into deliver code and new features, the application security team will help them to secure their code as they know the common mistakes and assumptions done by developers. Since the AppSec guys' mind is security oriented, their focus are to break things, guide how to fix them, and be aware of new vulnerabilities. They can elaborate proof of concepts to demonstrate how an attacker is able to leverage a vulnerability. This will help not just developers, but also the management team to remember them to not skip security. Even when a developer is facing a security issue, like for example an ASP tool, and don't understand how the code is vulnerable, the security team can be helpful. They are a kind of security seal of approval to a developer or someone which is not sure if the code is vulnerable or if it is vulnerable. Clarify the right way to fix it. Here, communication is an essential skill to developers understand their feedback. Next, George will talk about the triaging process. George?
Thanks, Eduardo. So at this point, if my organization adopts a SaaS tool implemented within the SDLC, checking for vulnerabilities, and an AppSec team to help developers build secure code, create awareness, and keep in touch for new vulnerabilities, it's all going to be all right, right? No. This looks like a perfect and well-organized plan in theory, but in practice, things are a little different. Security tools tend to point out blocks of code that should be a target for manual review, even if the tool cannot provide that they represent exploited vulnerabilities. This means the output from a SaaS tool still requires human review, which led us to the main topic of this talk, triaging SaaS results. Everything seems perfect, but triaging results is not just looking for all results flagged by SaaS and correct those issues one by one. We already know the main goal of a SaaS tool, find vulnerabilities in app source code. But the output of SaaS is not just like, look for the results, read the flagged vulnerabilities, fix the code. SaaS is not a perfect tool, and after a scan, we could have a low number of results, which might be a good sign or not, or the scan can output a large number of results too. Since the demand for delivering code is a priority, applications generally have lots of lines of code with more lines of code. The probability to increase the number of results is high. SaaS aims to automate the manual source code review, which gives more speed to find vulnerabilities and deploy fixes before production. But more speed also means more noise. And by noise, I mean producing false positives and false negatives. Code quality tools try to flag a low number of false positives and can accept more easily false negatives. However, when it becomes about security, the paradigm is slightly different. Missing a security bug is not a desirable issue. As a result, security testing tools commonly produce more false positives in order to try to reduce false negatives. So, what if the output of a SaaS scan has 2,000, 7,000, or even 15,000 findings? How do you review all those results before the delivery date? Is this a human feasible task? How many false positives are in those results? Developers who face a long number of false positives might ignore relevant results, which might be severe vulnerabilities. Usually, this is where the panic monster awakes and asks, how we will handle this amount of results in time with all these restrictions? This is where the best practice recommendations enters in scene to handle all those headaches you might get. So, as mentioned before, triaging SaaS results is no easy task. It demands knowledge, patience, and a great frustration fighter inside you. We both used to often ask ourselves, so can we optimize our time and effort triaging these tons of results, keeping in mind that we must never lose our AppSec point of view? And the mindset was always to divide and conquer in order to achieve a better answer. However, after some time, we then realized that we could enhance a few simple guidelines to make our daily routines more efficient. These guidelines are divided into 3 different phases: pre-analysis, during analysis, and post-analysis. From now on, we will refer as analysis the process of triaging the results of a scan. So the first one is the pre-analysis. And which is this phase? As the name says, this phase happens before the results arrive at our desks. It can be while the scan is being made or even before that. We suggest that you take the opportunity to do a little research on the app, which is being tested, and the context to know the purpose for it being created. Another important tip is to know which are the more common vulnerabilities in that kind of language and frameworks. At least, they're common inputs and sinks. This will provide better speed to triage results during the analysis stage. For anyone who does not know what an input or sink means in the context of triaging results, an input is the first node of the flow of a determined result vulnerability of your application, whereas a sink is the last node. For example, considering a result of reflected cross-site scripting, the input will be the entrusted data from the user, and the sink would be the node where the data is reflected from the server back to the client. Those are two crucial definitions for the process of analysis, which lead us to the second phase. The second phase is characterized by the aim of the target goal mindset. You should always focus on the higher vulnerabilities first, so you can be sure of how exposed your app is. On the other hand, those vulnerabilities are also the ones who require more from the analyst, the most effort. They possess bigger flows and sometimes the trickiest ones. At the same time, during the analysis, the look for input sink, if it makes sense, is always a good elimination technique. And what does it mean? Imagine you are once again looking at that reflected XSS result. If the input is not tainted data or is properly sanitized, you won't need to look for the rest of the flow, triaging it as a false positive. In the same way, if the input makes sense, aim next for the sink to see if it's a good handling node. For example, if in that case of the reflected XSS, if the data is not sent anywhere, you can triage the result easier. Next, if those two nodes make sense for that kind of vulnerability, you will need to look for the entire flow. Another thing to always keep in mind is to look for standardized results. For example, there's a result that has an input which does not make any sort of sense for that kind of vulnerability, being easy to triage as a false positive. The goal is to automate this process by using some sort of custom script that will look for all these results in that vulnerability, whose input starts that way. With this, you will feel relief for not having to triage any single one by hand. Now, Eduardo is going to tell us about the post-analysis process tips. Eduardo?
Continuing Jorge's lead. After finishing the analysis process, what can we learn from it? Is anything we can improve to make SAS flagging less false positive results? Less false positives is equal to less noise to filter. We can make the same exercise for the triaging process. What could we do to improve the triaging speed? Should we focus on learning a specific vulnerability that got us stuck for a lot of time in their attack flows? What were the developers' assumptions which led their code to be vulnerable? These are just examples of questions which can improve your analysis and at the same time the coding process. One thing that helps to speed up analysis is automation. You can find flow patterns that help to decide if the finding is good or bad. Automating this task can be the difference between spending 2 seconds or 2 hours classifying them. Besides that, with a lot of analyzed results, what confirmed vulnerabilities should we fix first? Well, prioritize them. Start with those with higher severity because they have a higher impact if exploited. Another thing to pay attention to is don't let ambiguous results to be a bottleneck of your analysis. There are 3 types of results: clear confirmed, clear false positive, and ambiguous result. Ambiguous results are the difficult ones which can slow down the analysis process. This type of results can have a logic hard to follow because it can be difficult to look the flow where the code is called or determine how an attacker will exploit it. Because of this ambiguity, you should avoid the exploitability trap. This happens when someone asks you to prove that This happens when someone asks you to prove that if some result is exploitable. This can be risky for two reasons. It's time consuming and it's not guaranteed that you can develop an exploit for it. It's time consuming because the time you put into develop an exploit would almost always be better to spend resolving other problems. About the second point, developing an exploit is a skill dependent on your knowledge. So what happens if you can't exploit it? Does this mean the flagged result is not exploitable? Or if you don't have the right skills to exploit it? As a result, it's better to fix the code and make sure it is safe, even if you are not sure if it is vulnerable or not. It's better to correct the bug and be sure that it's safe than assume that might be safe and no one will exploit it. When the goal is security, there is no chance to facilitate and let bugs create a hole in your application. Well, for the final words, we'll make an overview of what we were talking about. If you want implementing application security, you need to test your software, whatever AS tool you use. But it's not the only thing to consider. Implementing application security testing is a must, but more important is the communication between developers and the application security team. As developers have the best knowledge of the code and the security team has a security mindset, working as a whole is a key factor to develop a better product. Also, the triage process is not only just about fixing each finding. It must be carefully analyzed and prepared to not hinder productivity. And just have always in mind, don't put security away from your SDLC and assume everything is fine. We finish our presentation with this quote: "A fool with a tool is still a fool." Regarding the subject of our talk, it's not enough to have just a good AS tool, but also it is important to know your problems and fix them using those tools. It does not make sense if you don't use the potential of an AS tool the right way. Thanks for watching and stay safe.